Section 5.2, Discovering Properties of Parabolas. So first we're going to fill out this chart that we have here. Now notice that we're given all of these functions and we want to fill everything out. So remember we talked about the standard form for a quadratic equation, which is ax squared plus bx plus c. So the a is always in front of the quadratic term, the b is always with the linear term, and the c is your constant. So if we look at the first equation that we have here, we have y equals x squared. Notice that there is no linear term and there is no constant term. So because there's only a quadratic term, that means that I know b is 0 and c is 0 because they're not there. So in order to find out what your a is, you look in front of your quadratic term. So what's in front of our a when there's no number there? Remember, it's 1. So we have 1, 0, 0. So then if we look at maybe like this equation right here, notice that that one doesn't have a linear term, but it has a constant term now. So in front of my quadratic term, my a would be 2. My b in this case is going to be 0, and my c value is -4. Whereas when we have this equation right here, I have an a value of 1, I have a b value of 6, and I have a c value, my constant term, is 8. So why don't you take a second and pause it and see if you can fill out the other terms, and I'm going to do that too. So if we go to the next one, I know that this has a 4, this would be 0, 0. This one would be -2, 0, 0. This one here would be 3, 0, 5. This one is hard to see there, I know, but it's 1/2 on your paper. 0, 1, and then we have -1, 4, 2, and then -1/3, -2, -3. So those are all the a, b, and c values. And these values are important because they help us kind of figure out some other things for our graph. Now you'll notice we have this right here, which is -b over 2a. And we'll talk about that relationship in just a minute. So let's just go ahead and start computing some of this. So let's look at the first equation that we have. For number 1, -b, so your b value is 0. So we have -0 over 2 times a, which is 1. So that gives me 0 divided by anything is just 0. So I have 0 here. Now, we want to figure out whether or not this graph opens up or down. So remember we talked about looking at the a value. So all these a values tell us whether a graph is going to open up or down. If it's positive, remember your graph opens up, and if it's negative, your graph is going to open down. So when a is greater than 0, opens up. When it's negative, it opens down. So it's easy to look at this first one. Our a value is positive. So since our a value is positive, I know the graph is going to go open up. And now we can do this for all the other equations. So 4 for the next equation is positive, so it opens up. So the next one's -2, so I know this one's going to open down. And this one would be up. And then we have up again, up, and then up, down, and down. And I know those last two are negative, that's why they're opening down. So now the next thing I want to do is I want to look at my axis symmetry, vertex, and y-intercept. So let's do the y-intercept because we've talked about the y-intercept before. To find the y-intercept, you plug 0 in for x and solve for y. So if I plug 0 in for x here into this equation, this would be 0 squared. So 0 squared is just 0, so your y-intercept in this case is going to be 0. Now if we go to our graph just to go ahead and look at it, so I'm going to plug this into my calculator, y equals, to kind of help me out. So in my y equals, I have y equals x squared. And if I hit zoom 6, because you guys probably don't have a nice standard winner because we were graphing those other equations before, this is what I get. So notice that my graph is opening upwards, so I was correct. And if I hit the trace button, notice it starts on 0, 0. And if I go around, it looks like that is actually my vertex of my equation, which we talked about before. It is our vertex. So if I go back to my equation, this -b over 2a is going to be, for this equation, my vertex. So remember, your axis of symmetry is always the x-coordinate of your vertex. So 0 is the x-coordinate of my vertex, so x equals 0. So then the next question is, how do you find the vertex? So that negative b over 2a, if you were to graph all these equations, you would see is actually the x-coordinate of your vertex. So this is the x-coordinate of the vertex. Well, so if you know the x-coordinate of the vertex, how do you find the y? You plug that x-coordinate back into your original equation. So remember, we have function notation, so f of negative b over 2a is going to be your y-coordinate. So that means, again, that all we're doing is just we're plugging in negative b over 2a into the original equation and solving for y. So that's how you find the y-coordinate of your vertex. So if we go back up here, if I plug 0 into my equation again, which I've already done, 0 squared is 0, so I know that my vertex is at the coordinate ordered pair 0, comma 0. So then let's go down to this problem right here that we started at before. So let's do negative b over 2a. So my b value is 0, so I have negative 0 over 2 times 2, so that's 4. So negative 0 over 4 is just 0. So again, that's 0. So that's the x-coordinate of my vertex. Remember, that's also the axis of symmetry, so x equals 0. Now if I want to find my vertex, I plug that into my equation. So I'm going to do the math off to the side. So I get y equals 2 times 0 squared minus 4. So 0 squared is 0, 0 times 2 is 0, and 0 minus 4 would be negative 4. So my vertex now is at 0, negative 4. And if I want to find my y-intercept, you plug 0 in for x and solve. Well, my x of my vertex was 0, so I already know that it's going to be, again, my y-intercept is going to be negative 4. So then let's go to this other one down here. So this equation, let's do the same thing. So negative b over 2a. So in this case, negative b is negative 6 over 2 times 1. So now I have negative 6 over 3, or, oh, sorry, negative 6 over 2. And what's negative 6 divided by 2 is negative 3. So now I know the x-coordinate of my vertex is negative 3. So now that I have that, I know the axis of symmetry is x equals negative 3, because remember, it's a line of symmetry. And if I want to find my vertex, I can plug this into the equation and solve. So I get y equals negative 3 squared. Don't forget to put parentheses around what you're plugging in, because you're squaring that negative as well. So if you do this in your calculator, or if you do this by hand, you would see that your y value for your vertex is going to end up being negative 1. So that means my vertex is at negative 3, negative 1. And then that means that if I want to find the x-coordinate of, or the y-intercept of my graph, notice I didn't plug 0 in for x this time, I plugged in 3 for the vertex. So the vertex is not the same as the y-intercepts. Now I have to plug in 0 to find it. So I'm going to do that math again off to the side here. So y equals, if I plug in 0, I get 0 squared plus 6 times 0, and then plus 8. So when I do that, I get 0 squared is 0, plus 6 times 0 is 0, so 0 plus 8 is just 8. So my y-intercept is 8. So now I have 8 here. And notice that that y-intercept is different than the vertex in this case. And I can keep doing this for all the problems. So those ones that are left up there, I want you guys to do the same thing. And remember, you can always plug this into your calculator and check your answer. So I'm going to plug in that bottom one that we did, the last one, just to show you guys that you can check doing this. So on my calculator, if I go to my y equals, I'm going to plug in x squared plus 6x plus 8. And if I hit graph, notice that I can hit the trace button right here. And if I hit the trace button, use your left and right arrows, I can see that It's not going to give me the exact value when I hit trace, but I'm around -3 and -1, which is what I had. If I go to second trace, which calculates the value, if I put an x value of 0 in and hit enter, notice that gives me my y-intercept, which we had, which was 0, 8. So that looks like we're doing some stuff right here. So that's my graph. So again, you guys need to finish those other equations that we have, and then you're going to want to check your answer. So now we're going to get to the notes part. So you should have finished the chart, and like I said, we'll talk about that in class. So 5.2 properties of parabolas. So when b is not equal to 0, both a and b are going to affect the position of the axis of symmetry. And what am I talking when I'm talking about a and b? I'm talking about your standard form for your quadratic equation. We can use the values of a, b, and c to find the characteristics of a quadratic function using the properties and from the chart that we just filled out. So remember, these are properties that we talked about. So these are things that you need to have memorized. So make sure that if you didn't know that, you know it now. So when a is greater than 0, the parabola opens up, which means you have a minimum value. When a is less than 0, the parabola opens down, which means you have a maximum value. And remember that the maximum or minimum value is the y-coordinate of your vertex. The axis of symmetry is the line x equals -b over 2a. Why is that? Because remember that this is the x-coordinate of the vertex. I guess I didn't realize it was written down here. So the x-coordinate of the vertex is -b over 2a, so we didn't really need to write that. And then to find the y-coordinate of your vertex, you plug this back into the equation at -b over 2a, and then you'll get your y-coordinate. The y-intercept is 0, comma, your c value, which you should have seen them from the chart. So to find, you plug 0 into x and solve for y, and to find the x-intercept, which we haven't done yet, you're going to plug 0 into y and solve for x. So let's go ahead and look at this first graphing example. Y equals 2x squared plus 4. So the first thing I always do is I write down my a, b, and c values. So in this case, a is equal to whatever it's in front of my quadratic term, the number, which is 2. My b value, which would be the linear term, there is none, so it's 0. And my c value in this case is positive 4. So that's my a, b, and c. Now from that, the first thing I always like to do is look at my a value. So my a value is equal to 2. Because of that, and it's positive, I know my graph is going to open up. So the parabola opens up. Remember, the parabola is just the shape of the graph, and remember, all of these shapes should always be a U shape. If it's not, then you did something wrong. So then the second thing that I'm going to want to find is my axis of symmetry. So remember, I always abbreviate A of S. So the axis of symmetry is next. So to find the axis of symmetry, you use x equals -b over 2a. So we have the coordinates a and or the variables a and b over here. A is 2, b is 0, so -0 over 2 times, in this case, 2, gives me -0 over 4, which is just 0. So now I have the axis of symmetry, which is x equals 0. So that's the line of symmetry. And remember, x equals means you have a vertical line. So then the third thing when I'm graphing that I do is I actually find the vertex. So now we're going to find the vertex. Now, remember, the axis of symmetry is also the x-coordinate of the vertex, so I know I have 0, comma something. To find that other number, I'm going to do y equals, and I plug that x-coordinate into my original equation. And remember, when you're plugging something in, put it in parentheses if you do it in your calculator. So here I get y equals 2 times 0 squared plus 4, so 2 times 0 squared is 0, so 2 times 0 is 0, so I get 0 plus 4, so I get y value of 4. So I know my vertex is at 0, 4. Now that I have that, the next thing I'm going to do is plot the vertex and make a table to find other points. So I know my vertex is at 0, 4, so 0 is at the origin, up 1, 2, 3, 4, so this is my vertex. I know my graph is going to be opening upwards. Remember that we talked about the line of symmetry is where your graph is going to be cut in half. So this right here would be my axis of symmetry at x equals 0. So it's not really there, that's why it's a dotted line, but it's just to show you that if I fold my graph in half on this line, remember we said it should match up, or you should have corresponding points on the other side. So then the question is, how do I get those other points? What I normally do is I plot the vertex first, which we already did. So we have 0, 4. And then I'm going to pick either on the right side or the left side points that are close to the vertex that I can plug in for x to find y. So I'm just going to pick some points to the right of 0. So what's to the right of 0? 1 and also 2. And remember, we kind of did this earlier in the year when we talked about absolute value graphs, which were their V-shaped graphs. We said pick 2 points to the left and 2 points to the right and then graph it. It's the same kind of idea. So now I'm going to plug in 0 for x to solve for y. So I'm going to do my math over here. So y, or not 0, sorry, 1. Y equals 2 times 1 squared plus 4. So 1 squared is 1, 2 times 1 is 2, so I have 2 plus 4, which is 6. So that's my y coordinate. So I have 1, 6. So 1 up, 1, 2, 3, 4, 5, 6, which is right here. And then if I do 2 into the equation, I'm going to do that in a different color. So y equals 2 times 2 squared plus 4. And again, notice I put it in parentheses. So when I do that, 2 squared is 4. And then 4 times 2 is going to give me 8 plus 4, which is 12. So now I have the next coordinates 2, 12, and that's, I think, off my graph, so we'll just do it a little bit higher. That's okay. So right 2, 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 would be somewhere up here. Now, the cool thing about these graphs is if you find one side, you don't really need to plug in the other side unless you want to check. But I know that I should have the corresponding point to 1, 6. So the corresponding point should be on the other side of the graph. So if this is right here, the distance from here to here is 1 away from my axis of symmetry. It should also be 1 away on the other side. So I know that that right there is the corresponding point. You don't really have a line there, so I'm going to erase it. But we know that we have 1, 1, 2, 3, 4, 5, 6. So this point here and this point here are what we call corresponding points, because when we fold our graph in half on this axis of symmetry line, they match up. And then that means that this point, if I count 1, 2 away from my axis of symmetry, I got 1, 2 on the other side of my axis of symmetry, so that would be the other point right there. And then, of course, I would take my pencil and I'm going to connect those dots with a U-shaped, so you should make a U-shaped curve like that, and that would be my graph. So if we look at this, we already found the y-intercept. So the y-intercept is when you plug 0 in for x and solve for y. In this case, the y-intercept and the vertex are the same. Again, that's not always the case. So I have 0, 4 for my y-intercept. And if you look at this, where's the x-axis? Right here. If I wanted to find the x-intercepts, notice that the graph does not cross the x-axis in this case, so there are no x-intercepts in this case, because the graph doesn't cross the x-axis. And now I'm going to go to my calculator and I'm going to check my work to see if I did all this correctly, because it's an easy thing to do. So if I go to my calculator, I'm going to go to my y equals and I'm going to plug this equation in. So 2x squared plus 4. And if I hit zoom 6 for nice standard window, here's my graph, and notice I can see my vertex. If I hit trace, you notice it's at 0, 4, so I know that's also my y-intercept, since it's the same in this case. If I go to my table, I can also confirm 0, 4, 1, 6, 2, 12, so the corresponding point to 1, 6 was negative 1, 6, and then negative 2, 12. So it kind of goes around wherever your vertex is, which is why it's nice to find your vertex first. So I'm going to go back to my graph, because there's one last thing we want to talk about. Whoops, wrong way. So the last thing I want to talk about that I didn't here is the vertex. The vertex in this case, notice it's the lowest point of your graph, so the vertex is a minimum. So I'm going to write that down as well. So this is a minimum. And the minimum value, remember, is the y value of your vertex. So in this case, which is 4, so the minimum value of the graph is, in this case, 4. So that's something else that we also want to talk about when we're doing these equations. So let's go ahead and do this next graph together, and then you guys are going to do number 3 in your own to finish up your homework. So again, the first thing I want to do is write down my a, b, and c values. So a is with my quadratic term, which 1 is in front of that. B is -2, and C is -3. So now that I have all those values, if I look at my a value again is 1, so because it's positive, I know my parabola opens upwards, so graph opens up. Fix that. So now that I know my graph opens up, I can find my axis of symmetry. So my axis of symmetry, remember, is the x equals -b over 2a formula, which you just have to memorize. So when I plug this in, I get -2 over 2 times 1, so that's really -2 over 2, which is -1. So I know my axis of symmetry is x equals -1. The next thing I'm going to want to find is my vertex. So remember, your vertex is the -b over 2a, so -1, comma. So if I want to find the y-coordinate, I'm going to plug the x-coordinate into my equation. So y equals -1 squared minus 2 times -1 minus 3. And again, notice I put it in parentheses. -1 squared is +1, and then -2 times -1 gives me +2 minus 3. So in this case, I have, what am I missing? Oh, if you go back to your axis symmetry, it's -b. Your b value is negative, so this should have been negative. So this should have been positive. So this is +1. So this should be +1, and that's going to change. So sorry about that. So that would be 1 minus 2 minus 3. So 1 minus 2 minus 3 is going to give me a y-coordinate of 4, and of course it's negative. So then that means that the vertex is at +1, -4. So I'm going to go ahead and start to plot this. So I have right 1 down 1, 2, 3, 4, which is right here. So that's my vertex. Ooh. And I'm sorry about that. I didn't realize I hit the button on the smartboard. So we're just going to do this real quickly. Okay. Sorry about that. So I got my vertex. Now I also know that my axis of symmetry, remember, is the line. Oh, I did it again. Sorry, I didn't realize that I keep hitting that button. So is the line that, remember, cuts the graph in half. Oops, and that's off. So that's my line of symmetry, and sorry, it's a little off. So now I need to figure out how the rest of my graph goes. So remember, that's when you make your table. So I'm just going to make my table over here. I already have my vertex, which is 1, -4. Now I need some other points. So if I have an x value of 1, I'm going to just pick 2 to the right. You could also do the left, so I'm going to pick 2, and then I'm going to pick 3. So an easier way to do this instead of doing it by hand is just plug it into your calculator. You might as well if we have our calculator. So that's what I'm going to do real quick. So I'm going to go to my y equals in my calculator. I have x squared minus 2x, and then minus 3. So if I go to my table, second graph, I know my vertex should be at 1, -4, so which it is. Notice the points around it, the y values should be the same if they're corresponding. The only time it doesn't work is if you don't have an integer for your x-coordinate of your vertex. If it's like a decimal or something, it makes it not look like it's the same. So notice that we have 2, -3, and 3, 0, and then we also have the other corresponding side. So I'm going to go back to my notes and just write this down. So we had 2, -3, and 3, 0. So I'm going to plot those. So 2, negative 1, 2, 3, and 3, 0 would be here. So remember, on the other side of that line, that's our axis of symmetry, we have our corresponding points. So this point right here corresponds with 2, negative 3, and this point right here corresponds with a 3, 0. So now that I have those points, I can go ahead and connect them for my U-shaped graph. Oops, and I think I was a little bit off there. I didn't realize I didn't go one more over. So the corresponding point for that one should have been here. It's hard to tell in this graph sometimes. And then connect the dots. And if we look at this, notice that this vertex is the lowest point of my graph, so it's minimum. So before I do that, the next thing I'm going to talk about is the y-intercept. So my y-intercept in this case is right here, and I got that from my corresponding point. So 0, negative 1, 2, 3. So 0, negative 3 is my y-intercept. So I'm just going to write down 0, negative 3. I can see my x-intercepts by looking at the graph. So my x-intercepts, I know I have right here and here, because it's where it crosses the x-axis. So at 3, 0, I have an x-intercept, and I also have one at negative 1, 0. And then again, the last part I'm going to talk about is that this is a minimum for my graph. So the minimum value is, and remember it's the y-coordinate of your vertex, which in this case is negative 4, so negative 4 is the minimum value. And again, why is that? Because notice that this y value of negative 4 is the very lowest y value of my graph. There are no y values that are lower than that, so that's why we use the y value to tell. So the minimum value is at negative 4. So what you guys should do is finish up that chart and do question number 2 right here. And then, like I said, we'll check that in class. I will also go ahead and put the answers to the chart up on my website under the homework answers, so you can, when you're done with the chart, check it online. So again, you're finishing the chart, and you're going to do this problem right here, and then we'll finish the rest of the notes in class.